Hi guys, this is Haribabu from SNS College of Technology, belongs to Computer and Design Department. Now the subject is about electrical circuit and electron devices. In Unit 2 AC circuit, we are going to see the topic is impedance, power and power factor. Let us see. In this, the topic of discussion is fundamentals of AC power, concept of instantaneous power, mathematical derivation of instantaneous power, power and resistive, inductive, capacitive load, average, reactive and apparent power, power triangular representation, definition significance of power factors and types of power factors, that is lag, lead and unity, and the effect of low power factor on system, method of power factor improvement, measurement of power and power factor, industrial and real world application, and summary and future scope. These are the topics we are going to discuss now. Okay, let us see. Okay, the fundamentals of AC power. What is fundamentals of AC power? Just see the alternating current is moving out. Okay, alternating current is moving out. The fundamental is the change the direction and magnitude with time. That's the fundamental thing we have to know about the AC. Okay, and AC voltage and current are sinusoidal in nature. That is, it is sinusoidal, sine waveform. And power in AC circuit is not constant. It varies with time. The three major types of power is real power, reactive power, and apparent power. Okay, what is real power? Actual energy consumed. Okay, and that is real power. Next is about relative power. Sorry, reactive power. Reactive power is energy stored and released. So energy is stored and then it will be released out. Okay, that thing will be the reactive power. Next is about apparent power. The total supplied power. That means we are supplying the power. No, that's the total supplied power. So consumed and energy stored and released and total supplied power. These are the things we going to see in fundamentals of AC power. Next. Okay, concept of instantaneous power. In this, the instantaneous things has been happening of power, active power, and instantaneous power, and instantaneous reactive power. So actually, we discussed in previous slide, no, the real power, reactive power, and apparent power. Like that, it is a active power, reactive power, and instantaneous power. Okay, like this we are mentioning out. Okay, defined as a product of instantaneous current and voltage. That is formula P is equal to V into I. That means in case of time, so V represent as P of T is equal to V of T into I of T. So it represents the rate of energy. It represents the rate of energy. Represent the rate of energy at any instant of time. So varies continuously with the phase and difference between the voltage and current. So there will be a voltage difference in phases. Okay. Next. So mathematical representation of our instantaneous power, we're just going to see. Let V of t equal to V of sine omega t, where Vm represents the voltage maximum. Sine omega t represents it's a sinusoidal waveform. The omega t represented, omega is a angular frequency and t is a time. So similarly I of t. I of t is equal to Im sine omega t minus pi. What is pi? The angular difference between the voltage and current representation. Okay. Then P of t is equal to the both term has been multiplied and we getting the some value. Using trigonometric, we know the formulas. So Vm sine into sine. Okay, that's the term. So it will be represented as Vm Im by 2 cos pi plus cos 2 omega t minus pi. This is the answer term. Okay, that is just addition of two terms and minus of two terms. So that is omega t plus omega t minus, it represents minus. So 2 omega t minus pi. Whereas in this omega t minus omega t plus pi will be cos pi. So that the term will represent it. Okay. So first term is constant average power and second term is oscillating. Okay. Second term is a oscillating. First term is a constant average power. Okay. Next. So power in resistive, inductive and capacitive. We can just see here. In inductive or resistive, we're just going to see here. Voltage and current are in phase. That is, it will be same phase. The power always positive. Whereas in inductive, current lags voltage. So it will be lagging the voltage. So power alternate between positive and negative. Capacitive load current leads the voltage. So inductive is current lagging, whereas in capacitive it is a leading. Similarly, alternating pattern, the average power of inductive capacitive loads is equal to 0. So no net energy consumption, whereas in the inductive and capacitive sections. The average reactive and apparent power. So representation as Vrms, Irms, cos phi. It is the average power. Reactive Vrms, Irms, sin phi. Where apparent power Vrms, Irms only. That is a no phase. Okay. So we're just going to see actual power consumed by resistive component is the average power. Reactive is power alternately stored and released by L and C. Whereas apparent power, the product of RMS voltage and current, represents the total power flow. Okay. Next, the power triangle representation. In this, the right angle triangle PQS has been represented here. PQS has been represented here. So S is equal to, by the Pythagoras theorem, S is equal to that is root of P square plus Q square. This S square is equal to the same term representation. You can represent it. So base is equal to real power and perpendicular to reactive power, and hypotenuse is a apparent power. So relation is S square is equal to P square plus Q square. The angle between S and P denotes the phase difference. The definition on the power factor, and the power factor is cos phi is equal to P by S. What is P here? Just think about it. It's a real power. S is apparent. Okay. So indicate efficiency of power utilization. So I power factor, efficient system, low power factor, energy losses. So utility factor 1.0 means all supplied power is effectively used. The types of power factor, lagging, leading, and unity. Okay. It is a unity. First thing is about unity. The both thing will be at same zero level, crossover at each point. Whereas this one, it is a voltage and current, lagging power. The current is lagging. In this, current is leading. Okay, this thing. So example, we just current lags voltage, inductive load mean it is a motor transformer. Leading power for current leads voltage, that is capacitor load, that is capacitor banks. Okay. In unity power, it will be using purely resistive loads. Okay. Somebody is looking again a future trend involving a integrating power factor monitoring with AI based smart systems, enabling real-time analysis, predictive maintenance, and automatic power factor correction. Such intelligent systems can optimize energy usage dynamically, so improve grid stability and enhance overall energy efficiency in industrial and commercial setups. So this thing will be the summary and future scope, and this going to say, and you guys can think about the future scope also. Thank you.